Hello, welcome back to our channel. Don't forget to subscribe and turn on the notification bell so that when we upload new videos, you'll be the first one to see them. Right now, we are going to concentrate on the paper which was written in KwaZulu-Natal province, grade 10, mathematics common test, March 2024. The paper was having 75 marks and it was written in 1.5 hours, which means 1 hour 30 minutes. Then let's go to the instructions. Here are the instructions of our paper. Read the following instructions carefully before answering the questions. You are told the number of questions. You are required to answer all questions. Then number the answers correctly according to the numbering system used in this question paper. So you have to take note that it's very important how you number your work so that you don't lose marks unnecessarily. You have to number your work following the order, following the numbering system that is being followed by the question paper. You are required to show all working, all calculations, diagrams, graphs, etc. which you have used in determining your answer. Answers only will not necessarily be awarded full marks, so you have to make sure that all the working is shown clearly. Then you are told you may use an approved scientific calculator here, non-programmable or non-graphical. Unless stated otherwise, you need to have your own calculator. If necessary, round off answers to 2 decimal places. Take note there. Unless stated otherwise, diagrams are not necessarily drawn to scale. Take note there. You are expected to write neatly and legibly. So once we have understood the instructions, we go to the questions. So we are now on our questions. Here is our question 1. The first question is saying indicate whether the following numbers is rational or irrational. What you have to take note of is the definitions of those numbers. If we are saying a rational number, it's a number that can be written in the form of a fraction, a over b, where a and b will be integers, and an irrational number cannot be written as a fraction. This one. So take note there. Root 15, square root of 15. Once any number which is under a root sign is positive but not a perfect square, it therefore means that such a number is irrational. If it's negative, it means the entire number, square root of a negative number. It therefore means that number is non-real. If it's not a perfect squares, we are talking of numbers we obtain by multiplying, for example, 1 times 1. The result, which is 1, is a perfect square. 2 times 2, the result, which is 4, is a perfect square, and so on. 10 times 10 is 100, so it means 100 is a perfect square. So 15, as we can see, is not a perfect square, so it means this number is irrational. Then we are given 2,5. 2,5, any terminating decimal fraction, you just have to know that it's a rational number. It can be expressed as a fraction. So the second one is rational. Then we want the cube root of 8. Cube root of 8. Is there a number that we can multiply itself 3 times to get 8? So if you check, this 8 is 2 times 2 times 2, implying that the cube root of 8 is 2. So it therefore means 2 is also a rational number. And then the last question is 2.333, and as you can see, the 3 is ongoing, meaning to say it's a recurring fraction, we have to know that all recurring fractions are also rational numbers. So recurring is a rational. Terminating fraction, which is having a strict last digit, like this, 2,5, it's a rational. It's terminating. The numbers are not going continuously. If it's non-terminating and it's not recurring, it therefore means it becomes irrational. Then we go to the next question. So it's saying, write down two rational numbers between root 2 and root 10. Between root 2 and root 10. If you check rational numbers, yeah, we can check 1. 1 is a number before, so we cannot use 1. If we check 2, 2 squared is 4, so 2 is greater than root 2. So here we can put 2. What's happening? So we're saying what number? So we found that 2. So we can, 2 is greater than. If we check 3 is greater than. So this one just said rational numbers, but you have to take note that there are many numbers apart from 2. 2 and 3 are the only whole numbers between root 2 and root 4. But when it comes to rational numbers, you can even decide to take a fraction. For example, you can take a number like 5/2, which is, you can write any fraction. There are a lot of fractions that can be accommodated in between here, which are also rational numbers. You have to take note, rational numbers are not only restricted to whole numbers. So we have to take note of that. There were a lot of numbers that we could put, but they only requested 2. Then the next question, write down that one as a fraction. So if you check, this one is a recurring fraction. So how do we solve that? You say let x be equal to the number that you are given. So it's 0.1. The one is recurring, as you can see there. Then the next step, multiply both sides by 10. If we multiply the x by 10, we are going to get 10x. Then the other side, if you multiply the given number there by 10, we are going to get 0. Multiplying any number by 10, we have to know that we are just going to move the comma to the right. So it becomes 1.1. The 1 will be recurring. Then from there, we are going to say, let's subtract this first equation from the second equation. So we say 10x minus 1x, we get 9x equal to 1.111111. Subtract 0.111111. So if you check the 1's after the comma, they will cancel out. We'll be left with 1. Then you divide both sides by 9. So conclusively, it therefore means 0.111111 will be equal to 1/9. Then we go to the next question. We are now on 1.4.1, that is difference of two cubes. If we check there, we are having a perfect cube, which is x cubed, which is subtracting 8, which is also a perfect cube, 2 to the power 3. It was established in the previous, we explained that in the first question. So when you have difference of two cubes, the factors are going to be x minus, you take the cube root, minus 2. The second bracket, you take this first, so, but it's now squared. Then here it's now going to be plus the product of this x and this 2. So it's going to be plus 2x plus the last term here squared, which is plus 2 squared. This will become x minus 2 x squared plus 2x plus 4. That becomes the answer. Then we go to the next question. We are required to factorize that on 1.4.2. 1.4.2. If we check, we are going to factorize by regrouping. You take the first two terms. What's the common factor there? As we can see, it's x squared. So it's going to be x squared. Then 2x cubed divided by x squared. We are saying x squared enters how many times into 2x cubed? You are going to be left with the 2x. Then x squared enters how many times into x squared? It's going to be plus 1. Then we take the last two terms. Here the common factor, it's negative 1. Then negative 1 enters how many times? Sorry, it's negative 3 because here 3 is common. It's negative 3, not negative 1, because we'll be looking for highest common factor, not just a factor. So it's negative 3. Yes, 1 is a factor, but we want the highest. So negative 3. Negative 3 enters how many times here? We are left with the 2x. It is positive. Negative 3 enters how many times into negative 3? We are left with positive 1. So conclusively, our answer, we are left with x squared. The repeated bracket, let's start with that. Though there is no difference, the repeated bracket, we are going to write it as 2x plus 1. There. Then the other bracket is x squared minus 3. If you check, here appears to be a difference of 2 squares, but if you check the 3, there it's not a perfect square, so we can leave it like that. Then we go to the next question, 1.4.3. The question, this is a perfect square. If you check, it's saying x to the power 4. It's a perfect square. Once the exponent is an even number, therefore means it's a perfect square minus here we can write it as 4 squared. So this reduces to here the square root, it's x squared. So minus the square root there, it's 4. The other bracket will be x squared minus, the signs change. Here we put minus, so here it becomes plus 4. This is difference of two squares, but if you are to check in this first bracket, as we can see, this 4 can be written as 2 squared. So it means we have again a difference of 2 squares. So it therefore means this reduces to x minus 2, then x plus 2. Then we copy the last bracket as it is, x squared plus 4. This becomes our answer. Then we move to the next question. We are required to simplify the following expressions fully. So it means this first term, everything in first bracket is multiplying everything in second bracket. So this is going to multiply that. So we are going to be left with 2x times x squared. It becomes 2x cubed. Then that 2x again is going to multiply the second term. It's a positive and a negative. When they multiply, they give us a negative. 2 times 2, so it's going to be 4x squared. Then we have this first term. It will again multiply the last term, positive and a positive. It becomes plus 2x. We are done with the first term. We'll go to the second term here, and this one, we are going negative and a positive. It will be a negative x squared. Then that second term and the other second term, negative and a negative, will give you positive 2x. Then the last term there and the last term there is going to give us a negative 1. Simplify that, we are going to get, first let's group like terms, 2x cubed minus 4x squared minus x squared plus 2x plus 2x minus 1. Simplify, we get 2x cubed minus 4x squared minus x squared. These are like terms. It becomes minus 5x squared. Then we are having 2x plus 2x. It becomes plus 4x minus 1. This becomes our final answer. Then we go to 1.5.2. So on 1.5.2, please don't forget that numbering is very important as requested by as highlighted under instructions. So here, it therefore means squared means we are multiplying this bracket 2 times. So it's going to be 3x plus 5. Then 3x plus 5. Again, the first, multiply the first there. It's gonna be 9x squared. The first will go to the second, becomes plus 15x. Then this one and the second here and the first is plus 15x. Then here we have that second and that second is plus 25. If it's simplified, it therefore means we are going to get 9x squared plus 30x plus 25. Then we go to the next question. So to answer the next question, which is 1.5.3, we need the laws of indices, that one as it is. So we have 2 to the power x. We just take that one as it is, minus the But you need to apply some laws of indices. There's a law which says that a to the power m over a to the power n, which can be written as a to the power m divided by a to the power n, must be equal to a, the base is the same, to the power m minus n, the powers subtract when we are dividing indices with the same base. So in this case, we have powers which are subtracting. So it means we can come and separate them this way. So it means this can be written as minus 2 to the power x divided by 2 to the power 1, which is, then we say all over, this is what we were doing. Then we have another law which says a to the power m multiplied by a to the power n must be equal to a to the power m plus n. So here our powers are adding, so it means we can come back there. So it means this can be written as 2 to the power x multiplied by 2 to the power 1 minus 2 to the power x. So from what is there already, we can now simplify. So on our numerator, this we have 2x. This can be written as over 1 because we have a fraction here. So to avoid the confusion, you can write this first 2 to the power x as over 1 so that we also have this here. Since we have here a fraction, so factor out 2 to the power x here. You'll be left with 1 minus here. You'll be left with 1 over 2 all over. We have a common factor again, 2 to the power x. Then in bracket, you'll be left with the 2 minus 1. The 2 to the power x will divide each other. So we are left with 1 minus half, it's half, divided by 2 minus 1, which is 1. Any number divided by 1 is that number. So our final answer here is 1 over 2. Then we go to the next question. The next question, we are having a fraction which is having 3 over x minus 4 plus 2 over x plus 3 minus 21 over that is equal to what? This is what you want to simplify. So this is a fraction. So first step, we have to factorize this denominator, which is too big for us to simplify. So if we are to factorize that, how do we factorize this denominator? Here, we have to check product is the coefficient here and the constant, they multiply that one. So product is minus 12. Sum, we are talking of the term with x squared and the constant. Sum, you take the middle term, which is a negative 1. So we now want factors. For us to get factors, we want two numbers. If we multiply them, we get a negative 12. If we add them, we get negative 1. So the two numbers, if we multiply them, we get a negative 12. We can have a negative 12 and 1. We can have 1 and a negative 12. We can have a 6 and a negative 2. We can have a negative 2 and a 6. We can have a 3 and a negative 4. We can have a, sorry, here we meant a negative. So the one negative, positive, so here, or we can have a negative 3 and a 4. But let's now check. When we add them, we must get negative 1. So the first set, we can't. The second set, if we add them, we don't get negative 1. The third set, we don't get -1. The fourth set, we don't get -1. When we are here, 3 plus minus 4, you get -1. This one, we get +1. So our factors are gonna be 3 minus 4. So it means if we are to factorize this denominator, if we are just to factorize the denominator, which is a squared minus a minus 12, we are now going to have a squared, where there is the sum, we substitute by the factors. So it's gonna be plus 3a. This, you now just put our variable which we are dealing with, 3a minus 4a minus 12. Let's factorize, taking the first two terms common, it's a. Then in bracket, we are left with a plus 3. Then here the common is minus 4. Then we are left with a plus 3. So our factors are a plus 3, a minus 4. So once we have factorized this, we now want to do the question. So it means this can now be written as 3 over a minus 4 plus 2 over a plus 3 minus 21 over, we now write the factors, is a plus 3 multiplied by a minus 4. Then from there, we need to get the LCM of denominators. LCM of denominators, which we can call the common denominator. Here we have a minus 4, here we have a plus 3, here we have a minus 4 times a plus 3. So it means the LCM of denominators is a plus 3, a minus 4. So it means you have to multiply each and every term, each and every fraction there multiplied by the LCM of denominators. So that is going to be equal to 3 over a minus 4. That one, it must be multiplied by the LCM of denominators, which is a plus 3, a minus 4. Then we move to the next term, it's plus 2 over a plus 3. That one, it needs again to be multiplied by the LCM of denominators, which is a plus 3, a minus 4. Then we take the last term plus, or it's minus 21 over a plus 3, a minus 4. Again there, you need to multiply by the LCM of denominators, which is a plus 3, a minus 4. Then from there, you need to simplify your algebraic manipulation. If you check the a minus 4 and the a minus 4, they divide. The a plus 3 here and the a plus 3 here, they divide. Then here, this will divide with this will divide with that. Then simplify, it means oh, sorry, I made a mistake. I thought we are solving an equation. I thought we are solving an equation. Sorry. everything that we did there, please don't forget that we are having everything there divided by a plus 3 a minus 4. So simplify that. We are going to have 3 times that is going to be 3a plus 9. Simplifying that, 2 multiplied by that is going to be plus 2a minus 8. Then it's going to have minus 21. This all over the LCM of denominators. So 3a, let's group like terms. We are going to say 3a, this one, plus 2a which is equal to 5a. Then we take the other ones. It's going to be 9 minus 8. It's minus 1. So it's 1. 9 minus 8, it's 1. 1 minus 21. It becomes minus 20. Always make sure that you use your calculator so that you avoid making mistakes. Minus 20 over a plus 3, a minus 4. But if we check on our numerator, it can be factorized further. We have 5, then we have a. 5 enters how many times into 5a is a minus. 5 enters how many times into negative 20? We see it's negative 4, all over a plus 3, a minus 4. Then you cancel, you divide. So our final answer is given as 5 over a plus 3. This is our final answer. We go to the next question. On our next question, we are on question 2.11. Here we are having two brackets which are being equated to 0. When brackets are being equated to 0, you just have to know that you have to equate each bracket to 0. So x plus 3 equal to 0, or x minus 1 equal to 0. Therefore, x is equal to, you transpose this one to that side, it becomes 0, minus 3, or x equal to, you transpose this one to this side, so it becomes 0 plus 1. Then this becomes our final answers. Then we get to 2.1.2. We first need to factorize this term. So for you to factorize a quadratic, you have to check factors, product, and sum. Product, take the first term, the coefficient of x squared, and the constant. If you multiply them, it's 4. Our sum in that case is the middle term, the coefficient there of is minus 5. Then we want two numbers. If we multiply them, we get 4, but when we add them, we get -5. Those will help us to get factors. So we are having 2 and 2. We can have -2 and -2. When we multiply, we get -4. We can have -4 and -1. We can have 4 and 1. Now let's check. If we add 2 and 2, we are not getting -5. If we add -2 and -2, we are not getting -5. -4 and -4, we are getting -5. 4 and 1, this one is wrong. So our factors, we are having -4, -1. So it means we have to rewrite our equation there. It's going to be 2x squared minus 4x minus 1x. From the factors here, we replace the sum plus 2 equal to 0. Factorize, taking the 2 first, it's gonna be common factor here is 2x. Then we'll be left with x minus 2. Then the last two terms from the sign there, it's -1. Then we'll be left with x minus 2 equal to 0. The repeated factor, we write it once, x minus 2. Then we have 2x minus 1 being equated to 0. Once we have two factors being equated to 0, equate each factor to 0, or 2x minus 1 equal to 0. So the x is equal to 2, or the 2x is equal to 1. Then solve, the x will be equal to 1 over 2 after dividing both sides. Then we move to the next question. We are on question 2.1.3. We are having exponential equations. If we check, we are having 2 to the power a certain number which is being raised, which is being equated to 64. So the first step, check if whether you cannot express this other number, 64, also in terms of in index form with the base 2. As you can see here, 64 can be written as 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64, 1, 2, 3, 4, 5, 6. So 64 can be written as 2 to the power 6. So it means our equation 2 to the power 3 x minus 1 can be equated to 2 to the power 6. Since our bases are the same, here we can therefore equate the powers. 3 to the power x minus 1 equal to 6. 3 to the power x equal to 6 plus 1. When you transpose that, it becomes 7. Then divide both sides by 3. So the x is equal to 7 over 3. Then we get to 2.1.4. Again, then index is an exponential equation. We have 27 raised to the power something, and we have 81 raised to the power something. As we can see, this can be written in index form with base 3. If we check 27, can be written as 3 times 3, which is 9, times 3, which is 27. So it means the left-hand side can be written as 3 to the power 3 for 27, then raised to the power x minus 2 being equated to 81. 81 can be written as 3 times 3, 9, times 327 times 381. So it's 3 to the power 4. So this can now be written, the other side is 3 to the power 4 for 81 being raised to x plus 1. But from the laws of indices, there is a law which says that if a is raised to the power b, then it's all again raised to the power c. That must be equal to a to the power bc. The exponents will multiply each other. Applying that here, since 3 is an exponent, then another exponent there, it therefore means we are going to be left with 3 to the power 3 multiplied by x minus 2 being equal to 3 to the power 4 multiplied by 2x plus 1. But since our bases again here are the same, here the base is 3, here the base is 3, we can now equate our powers. So simplifying here, we are going to have 3 times x is 3x. 3 times minus 2 minus 6 must be equal to, it becomes 8x plus 4. Simplifying, we can take the here to that side, it becomes minus 6 minus 4. When we take the 4 to that side being equal to 8x, when we take the 3x there to this side, it was positive, it becomes negative 3x. So we are left with the negative 10 being equal to 5x. Dividing both sides by 5. So here our x is equal to negative 2. This becomes our final answer. So going to the next question, question 2.2. Here is an inequality. Solve the inequality. That is the first part of the question. So to solve the inequality, we are having two inequalities here. The first inequality, you read from the beginning here of the inequality up to where the second inequality sign starts. So we are having minus 2 less than 4 plus 2x. And the other inequality, you read from where the first inequality ends there up to the end of the inequality. So it will be 4 plus 2x less than or equal to 6. Simplifying this, so here, first inequality we transpose that one to that side. It becomes minus 2 minus 4 less than 2x. Here it's minus 6 less than 2x. Dividing both sides by 2, we are left with minus 3 less than x. Then the other one, we are going to transpose the 4 to the other side. So we'll be left with the 2x less than or equal to 6 minus 4. Then 2x, always remember when we transpose, we change sign, less than or equal to 2. When we divide both sides by 2, we are left with x is less than or equal to 1. This is our question 2.2 here. So our final answer is this inequality, and this inequality is minus 3 is less than x, and x is less than or equal to minus 1. This inequality can be written as 1. It's going to give us minus 3 less than x less than or equal to 1. This becomes our answer. Then we go to the second part of the question, which is saying, and represent the solution in interval notation. If you are to represent the solution in interval notation, it's going to be minus 3, then 1. They are separated by a semicolon. Then where there is less than here, we put this type of bracket. Then where there is or equal to, we have to put a box bracket. Then we move on to the next question. So we move to the next question. We are going to answer question 2.3. So on question 2.3, here we are question 2.3. Solve these two simultaneously. So we can write the equations as 2, equation 1, this one, equation 2, this one. So using the substitution method, we make one variable subject of the formula in either of the equations. So we are going to have, use equation 1, we make x the subject of the formula. X is equal to transpose the 5 and the 3y. So when we take the 5 to the other side, it becomes positive. When we take the 3y there, it becomes negative. This one becomes our equation 3. Then we have to substitute equation 3 in the second equation, meaning to say wherever there is x in the second equation, we are going to put 5 minus 3y. So it's going to be 2, 5 minus 3y, where there is x there, minus 6y equal, plus 2 equal to 0. Simplifying, here it becomes 10 minus 6y minus 6y plus 2. Equal to 0. Minus 6y minus 6y is going to give us minus 12y. Then we transpose the other ones to that side. 10 plus 2 is 12. When it's transposed to the other side, it becomes minus 12. Divide here by a negative 12. Divide here by a negative 12. We are left with our y being equal to a negative 1. When we now want to solve for x, we are now going to substitute this y value in this third equation. So our x is equal to 5 minus 3y is minus 1. Sorry, it's positive 1. Take note there, a negative divided by a negative. Always remember to use your calculator. It's positive 1 here. So our x is equal to 5 minus 3. X becomes 2. So our y is 1. Our x is 2. Alternatively, on that same question, it was possible that we can use the elimination method. If we were to use the elimination method, it means we are having our equation 1, x plus 3y equal to, we transpose the 5, it's going to be 5. Then here, if we divide throughout by 2, on the second equation, the reason why we are dividing, when using the elimination method, we must make sure that either the coefficient of x or the coefficient of y look alike except for the sign. One must be positive, the other one being negative, but of the same size. So when we have that, we are going to have x minus 3y equal to the other side we end up having, when you transpose, because there was a 1, when it's transposed, it becomes -1. If we decide to eliminate x, since the sign of x are the same, we are going to subtract the two equations. So we said they must be the same. If we wanted to eliminate y, their signs are different. It means we're going to add the two equations, but we want to eliminate x, so we subtract the equation. X minus x is 0. 3y minus 3y is going to give us 6y equal to 5 minus 1, which is equal to 6. When we divide both sides by y, it means our y. So when we divide both sides by 6, it means our y will be equal to 1. Once we get our y being equal to 1, we can substitute in equation 1. So it means our x plus 3, our y, which is 1, must be equal to 5x plus 3 is equal to 5. Subtracting, transposing that 3, the sign changes. X is equal to 5 minus 3. Therefore, x is equal to 2. Then we move to the next question. Question 2.4. Question 2.4 is now a word problem. If we check, we are told the difference between two numbers is 5. Because we do not know the actual numbers, we can introduce variables to the number. So we have a bigger number and a smaller number. So to solve this, we do not know the numbers. Okay, 6 times the smaller number is equal to 4 times the greater number. Find the number. So since we do not know the numbers, let the two numbers be any variables. So we can say let the two numbers be A and B. So the difference between two numbers is 5. So we can now write, therefore, B minus A is equal to 5. So in this context, it therefore means B is greater than A. If we had used A minus B, it means A is greater than B. Then, so this one is guiding us on which one is smaller, because we say bigger number minus smaller number, we get a positive answer. So in this case, B is bigger than A. Then you are also given that 6 times the smaller number. So the smaller number we agreed is A, so it means 6 times the smaller number is equal to 4 times the greater number is equal to 4 times the greater number, which is B. So this is equation 1. This is equation 2. So with that, again, we are using simultaneous equations using substitution method. It means our B is equal to 5 transpose the A. It becomes positive A. This becomes equation 3. Then we substitute 3 in 2. Meaning to say wherever there is B, we are going to put 5 plus A. So 6A is equal to 5B. B is gonna be 5 plus A. So definitely 6A. We are going to have 6A being equal to 25 plus 5A. Transposing the 5A to the other side, it becomes 6A minus 5A. So the A will be equal to 25. Once you get the A value, to get the B value, it means we need to substitute the value of A in the third equation. So it means our B will be equal to 25 here 5 plus A, which is 5 plus 25. So our B is equal to 30. Take note, alternatively, using this, we can still use the elimination method. Let's check how elimination method was gonna work. So we are having 3. We are having the first equation is B minus A equal to 5. Then the second equation there it is. So if we transpose the 4B to the other side there, it becomes minus 4B. We have plus 6A equal to 0. So we want to eliminate B, so we are going to multiply by 4 throughout the first equation. So this first equation, we are going to multiply it by 4. We want the coefficient of B to look alike. So if we multiply that by 4, it means we end up having a third equation, which is 4B minus 4A being equal to 20. Multiplied, so simplifying. When you add the two equations, the first one plus the second one here is 0. Then 4A minus, there it is, it's 6A plus minus, so we are going to get 2A being equal to 20. Our A, divide both sides by 2, our A is equal to 10. We'll check if we ever make a mistake at the end. Then we are going to have substitute A in those two equations. So we are going to have B A and B. So we are going to have A substitute the A there. So it's going to say B minus 10 for A is equal to 5. Transpose this, it means our B will be equal to 15. So using this method, we got those two answers. Using this method, we got those two answers. And if we check, both answers are correct, because if we say bigger 30 minus 25, we are getting we made an error somewhere here. There must be an error in the first method. Let us try and rectify. Let us try and rectify here. Okay, let's go to the first method of substitution. We made a mistake on the substitution method. Can you take note here? We said 6A is equal to 4B, not 5B. So here it was supposed to be a 4. So avoid such mistakes. Here it's supposed to be a 4. So 4 times 5, it was going to be 20. It was not 5B. The question strictly said here it's 4 times, not 5 times as we had written there. Then plus 4. 4 times that is supposed to be plus 4A. Then transposing Here it was supposed to be 2a, 6a minus 4a. We are supposed to have 2a being equated to 20. Then dividing both sides by 2, your a must be equal to 10. Then once a is 10, it means our b was going to be equal to be 5 plus 10. Then here our b is 15. So it is very important that whenever we are writing, try to revise your work so that we avoid unnecessary errors. You see here, it was supposed to be 6a equated to 4b, but we ended up equating to 5b and we made an error. Because we used an alternative method, we ended up obtaining that error. But for the sake of our practice, and always make sure that we revise. Then we are on question 2.5. Question 2.5. We are told if p is equal to 1 plus 3 to the power x and q is equal to 1 plus 3 to the power negative x, prove that q. You are required to prove that q is equal to p over p minus 1. So your q, substitute the q, which is 1, minus 3 to the power negative x, which is being equal to p. P is 1 plus 3 to the power x there over p1 plus 3 to the power x minus 1. So this and that one are going to cancel out. We'll be left with 1 minus 3 to the power negative x equal to, distribute the denominator. On our denominator, we are only left with 3 to the power. So it becomes 1 over 3 to the power x plus 3 to the power x over 3 to the power x. And take note here, our sign is positive, not negative. From what is given, the value of q, there it is. So we are left with 1 plus 3 to the power x equal to, simplify, there is a rule from the laws of indices, 1 over a to the power m will be equal to a. Then we change the sign of the exponent. If we are removing a number from the denominator to the numerator, we change the sign of the exponent. So it therefore means this becomes 3 to the power negative x. A number divided by itself is 1 plus 1. Commutative law of mathematics, a, we have to know that a plus b is equal to b plus a. So this reduces. We can now conclude that our left-hand side is equal to our right-hand side. Then we go to the next question. So you are given a right angle triangle with sides P, Q, and S, and theta as shown below. Here's the triangle. Then you are required to write down. So A, tan theta. Tan, we know tan is given by opposite of the angle divided by the adjacent. So in this case, the opposite of theta here is going to be here, that side, and the adjacent is the side making that angle. Always remember the hypotenuse is always opposite the right angle. So it means our tan theta is going to be S, which is the opposite, divided by the adjacent, which is Q. Then we go for negative sine theta. This is going to be equal to negative sine. The definition of sine is opposite over hypotenuse. So in this case, opposite of theta is S. and the hypotenuse is P. Hypotenuse is always opposite the right angle. Then the next question is sec. So you have to take note, it's part C, sec squared theta. It's part C, 3.1.1. They say the sec squared theta, but you have to know that sec means 1 over cos theta, then squared. Just write the squared outside there. So how do you define cos theta? Take note there. Cos theta is equal to adjacent over the hypotenuse. And here we already agreed that adjacent is Q and the hypotenuse is P. So bringing that here, it means we are going to have 1 over cos theta. Our adjacent is Q over P. Then remember, everything is being squared. Always remember that when 1 is divided by a fraction, we just reciprocate the fraction. So it means this is equal to P over A. So in this case, it simply means this reduces to P over Q squared. And from the laws of indices, the exponent can be distributed to end up having P squared over Q squared. Then we move to the next question. If it is given that P is equal to 12, theta is equal to 35, calculate the numerical value of Q. So we just look for a ratio from the ratios that we calculated, which is incorporating P and Q and theta. So the one which is from the ones which we calculated, the ratio which is incorporating P, Q, and theta, we are having it there. If we do not want to use that, we can just, because we want to calculate the value of Q, so we can just use our cos, because our cos is going to incorporate P and Q. So let's go on question 3.1.2. We agreed that cos theta is equal to Q over P. Why did we use cos theta? Because, yeah, it's incorporating P, theta, and Q. So go and substitute theta is 35 degrees. So it's going to be cos 35 degrees equal to Q over P. P we are told is 12. So make Q the subject of the formula. So it means Q is equal to 12 cos 35 degrees. Then use your calculator. On your calculator, we are going to just say 12 multiplied by cos 35. So you have to find a calculator. Unfortunately, my calculator from the desktop is not working. So if I say 12 times cos 35, we are getting 9.9. There are a lot of numbers, but remember we had an instruction which said must be to 2 decimal places if not specified. So it becomes 9.83. number that is appearing on my calculator, it's giving me 9.829824.531. So to two decimal places, we want two numbers after the comma. We concentrate on this one. So since it's greater than 4, we just add there. That's how we ended up having the 0.83. Then we move on to the next question. It's saying if A is equal to 20 degrees and B is equal to 55 degrees, use your calculator to evaluate the following to two decimal places. So it simply means we have to put these values, substitute them. So here we are going to have a sign. Our A is 20 degrees plus our B, which is 55 degrees. Then add 20 and 55. We are going to have a sign 75 degrees. Then you go to your calculator. You have to punch sine 75 degrees. Sine 75 degrees. And we are getting 0.96529.826. This one, because our answer is needed to two decimal places, we concentrate. So it means it's going to be equal to 0.97 there. Then we go to the next question, tan squared B. So it means this is equal to tan squared B is 55 degrees. But this can be written as this is the same as tan 55 degrees squared, which means tan 55 degrees times tan 55 degrees. But on your calculator, you can put the first bracket, then you write tan. Okay, let's use it as tan 55 degrees squared there times tan 55 degrees. So it's going to be tan 55 times tan 55. We are getting 2.039606.729. But to two decimal places, we are going to come here, this number affecting this, so it becomes 2.04. We go to the next question. It's 2 cosec. So it becomes 2 cosec. It means 1 over. Means 1 over sine. So 2 times 1 over sine. Where there is A, we are going to put 20 degrees plus 5 sine 35 degrees times 5. Here it's 5 times, not 35, sorry, it's 55 degrees. So we can punch it on our calculator the same way we wrote it. There is 2 times 1 over sine 20 degrees then it's saying plus, sorry, there's no 5 there. There's no 5 at the beginning. The 5 is inside plus sine 5 times 55 degrees. So the final answer we are getting is 4.8514140102 to 2 decimal places. We are getting 4.85 concentrated at the number after the second decimal place. This becomes our answer. Then we go to the last question. Without the use of a calculator, show all the workings, determine the value, showing all the workings, determine the value of. So these are special angles, 45, 60, 30. So to deal with the special angles, so we are supposed to know these ones by heart. Strictly said, don't use a calculator. So we are having 30 degrees, 45 degrees, and then 60 degrees. Here we are having sine theta, where theta is represented by those angles, cos theta. We can also add the tan theta here. So here it's 1, 2, 3, all over. Here is 1, 2, 3, all over. So everything is going to be over 4, over 4, over 4, over 4, over 4, over 4. Then you put a square root throughout. So when you want tan, you have to know the definition of tan. Tan theta is equal to sine theta over cos theta. So in this case, if you want tan 30 degrees, we can just use this one. It's 1 over 2, square root of 1 is 1 over 2 divided by, for over, here it's root 3 over 2. Simplifying this, as we can see, it's a half multiplied by 2 over root 3. So our final answer here, it's 1 over root 3. 1 over root 3. So here we are going to have 1 over root 3. If you check, this one and this one are the same, so dividing same values. Here it's 1 for tan 45. Then the last one for 60 is gonna be root 3 over 2 divided by half, which reduces to root 3 over 2 multiplied by 2 over 1. The final answer is root 3. So here it's gonna be root 3. Then we are done. So we just go and substitute there. Where they sine 45, it's the root 2 over 2. For sine 45, it's root 2 over 2 For tan 60, here it's root 3. So we just put our root 3. But remember, it's being squared. Then we have O over cos 45. As you can see here, cos 45. There it is root 2 over 2. Root 2 over 2. Then plus sine 30. Here is sine 30. It's 1 over 2. Then simplify. Here the numerator divides with this denominator, root 3 squared. So we are left with 3 plus half. So eventually, the answer is 3 plus half gives us 7 over 2. This becomes our answer. Thank you very much.